Hello students, welcome to my channel Theory Math. So I'm going to be solving this question in a very interesting way. Now, since I have this, I want us to take note of some things. Now, check out, this is 11, this is x plus 11 and x plus 9. So there's something about plus 9 and there's something about plus 11. Okay, this is something that you need to take note of, okay, to make sure that this question is being simplified. Now, note that 11 is the same thing as 10 plus 1 and 9 is the same thing as 10 minus 1. Now, because of this knowledge, I'm going to substitute back into the equation. So that I'm going to have x plus, instead of 11, what I'm going to have is 10 plus 1. Okay. Now, this is all raised to power 4. Then minus, I'm going to have this x, and instead of 9, I'm going to have plus 10 minus 1. Okay. Now, this is raised to power 4 is equals to 80. Very important. Now, since this is what we have, then we take note of x plus 10 in this case. So therefore, we can say let n be equals to x plus 10. All right, so everything now boils down to n plus 1 all raised to power 4 minus n minus 1 all raised to power 4 is equals to 80. Very important. Now, let's take note of this, that if we have such an expression, then x raised to power n raised to power m is actually equals to x raised to power n m. So therefore, if I have x raised to power 2 all raised to power 2 is equals to x raised to power 4. So take note, since we know this particular thing, then we can come back to say this is going to be m plus 1 all squared, then all raised to power 4, all raised to power 2, okay, then minus, we are going to have n minus 1 all squared, then all raised to power 2 is equals to 80. Now, having this expression, so we can now use the difference of two squares, where if we have a squared minus b squared, is going to be a plus b into a minus b, right? So because we have that, then we can come down to say that this question is going to be n plus 1 all squared plus n minus 1 all squared, we have it in bracket, is into n plus 1 all squared minus n minus 1 all squared. We have it in bracket. So since this is equals to 80, all right, we can now go on to actually expand. So this is what I have. I'm going to have n squared plus 2n plus 1, okay. Then I'm going to have plus n squared minus 2n, then plus 1. Cover the brackets, okay. Now, the next bracket is going to be n, the same thing, n squared plus 2n plus 1. We cover it. Then minus, we have n squared minus 2n plus 1. Okay, everything is equals to 80. Okay, so let's take note of that, is equals to 80. Therefore, since we have that, then we can we'll come up with a situation where we are going to have n squared plus 2n plus 1 plus n squared minus 2n plus 1, okay. Then this is going to be n squared plus 2n plus 1, then minus n squared plus 2n minus 1, okay, is equals to 80. Now, watching this, I'm going to have n 2n squared. We have 2n squared, then plus 2, okay, very important. Now, into here, we are going to have 4n, all right? Everything is equals to 80. Now, factorizing this first, we are going to have 2 into n squared plus 1 into 4n is equals to 80. So 2 times 4, we're going to have 8n into n squared plus 1 is equals to 80. Now, we divide both sides by 8. We divide both sides by 8. And these by 8 so that this cancels this out. So that I'm going to have n into n squared plus 1 is equals to 10. So this is going to be n cubed plus n is equals to 10, which is n cubed plus n minus 10 is equals to 0. So it has led us to a polynomial problem where we can solve through a trial and error method. Now, what I'm going to do is by inspection, okay, I can now say that let n be equals to 2. Now, what do I mean there? You see, substituting 2, we're going to have 2 raised to the power 3 plus 2, then minus 10. And this is going to be 8 plus 2 minus 10, which is actually equals to 0. So, therefore, n is equals to 2 is a solution. All right? And n minus 2 is equals to 0 is a factor. Now, since we have it as a factor, we can go ahead to divide to find the other factors. Therefore, we can have it as n cubed. We are going to have n cubed plus n minus 10. Now, divided by n minus 2 to get other factors. Now, how do we do that? We use polynomial division. And this is how we do it. So we have this, and the numerator is always inside the denominator, which is n minus 2, should be somewhere here. So this is going to be n cubed plus 0n squared, then plus n minus 10. And the method of division is we are going to find something that multiplies n to give me n cubed, and that's going to be what? N squared. So this is going to be n cubed minus 2n squared. Now, having this, you subtracting, you are going to have 2n squared. So I'll bring down this plus n, all right? And if you check it out, this is going to be, I'll have plus n. Now, having plus n, I'm going to have, sorry, not just n, but I think you're going to have 2n. Now, having 2n, so I'm going to have 2n squared minus 4n. Okay, this is what I have. Then I'm going to subtract. Subtracting here is going to be what? 5n. So therefore, I'm going to bring down my minus 10. And what is going to be here will be plus 5. So here I'm going to have 5 and minus 10. So subtracting, I'm going to have 0, 0. So everything is 0, 0. So it is actually factorizable because it's a factor of it. So in summary, what I have now will be n minus 2 down into n squared plus 2n plus 5. Everything is equals to 0. Now, recall we already know, we know that we are going to have n minus 2 is equals to 0, or we are going to have n squared plus 2n plus 5 is equals to 0. Now, in this situation, we know that our n is equals to 2. So this is one of the solutions. Then let's check it out. We have n squared plus 2n plus 5 is equals to 0. Now, I suspect that this is not factorizable, that is, the solution to this is complex, okay, in the complex plane. But let's check some conditions. Now, if I have b squared is equals to 4ac, then the roots are real and equal, okay? Now, if b squared is greater than 4ac, then we have that the roots are real and distinct, okay? But again, if I have b squared is less than 4ac, then the roots are imaginary, okay, or does not exist in the real plane. So let's check it out. Now, how do we know ABC? Remember, this is n squared plus 2n plus 5, okay? And the general equation of the general format of a quadratic equation is ax squared plus bx plus c. Now, if you check it, you will now find that your a is equals to 1, your b is equals to 2, your c is equals to 5. So let's check it out. Now, we have b squared. B squared is equals to 2 all squared, which is equals to 4. Now, we have 4ac will now be 4 times a, which is 1, times c, which is 5, which is going to be 10. Now, if you check it very well, you now find out that b squared is actually less than 10. Okay, since it's less than 10, that is b squared now means, or I mean to say 4 is less than 10. So therefore, it means that b squared is less than 4ac. Hence, okay, it does not have a real root. Okay, so we can conclude that the only solution, the only real solution is n is equals to 2. Now, recall that we said x is equals to, I mean to say n is equals to x plus 10. All right, therefore, here we're going to have 2 is equals to x plus 10. So x is going to be 2 minus 10. So our x is going to be minus 8. So we've succeeded in solving this question from beginning to end. Okay, so I want to believe you watch and you enjoyed the video. So please subscribe for more interesting videos.